Hi, and welcome to today's little quickie that's going to be all about this bad boy right here. And it's going to be about how to maintain the proper alignment of the head when performing vertical movements on the head. Because these round column machines don't keep the head aligned when we loosen it off and move it up or down. Now there are a few pretty obvious ways of maintaining the alignment, and we'll look at those towards the end of this video. But obviously I'm going to want to explain things a little more so that we understand what's going on. And one thing that needs to be understood is that in general most people move the z-axis or the head on their mill way too often while they're producing a part. We should keep that movement to a minimum, and for that we want to work with a technique that I call the longest tool technique. But before we get into the explanation, I'd like to perform a little demonstration on hole drilling or precision hole drilling. So let's come in a little closer and I'll explain what I want to do. What we have here is a block of 6061 T6 aluminum that we're going to use to demonstrate precision hole drilling. Now, especially compare, because we're going to produce two pairs of holes in this block. One pair of holes that are going to be center drilled only and finished, so drilled and reamed on the drill press. And a second pair of holes that are going to be center drilled here, but they're going to be drilled and reamed in situ here. And then we're going to go over to the surface plate, and with pins and gauge blocks we're going to comparatively measure the spacing between the first pair of holes and the second pair of holes. Not the relationship between the pairs, but the relationship of each pin inside of a pair of holes. I don't know if you can see it here, but I've punched two letters on the surface, A and B, so the two holes that are going to be next to the A, or if you prefer the A holes here, well, are going to be just center drilled on the mill. And the two holes that are side to side from the B, or the B holes, well, are going to be finished in the mill. I want to compare the difference between the two pairs of holes. I don't want to compare setup differences or alignment differences or all that. So I'm really going to be just measuring the distance between the two holes and not between a hole and the edge of the part, because then the squareness of the part can affect the end result. And that is why I've mounted the block in the drill press vise. It's not something that I would normally use to work on with this machine. But since I want to reduce the variables, I'm not going to take the part out of this vise once I'm done on the mill. I'm going to take the vise off of the mill and bring the whole setup over to my drill press to keep things on a level playing field. And to make sure that I start out on that level playing field, well, I have a small 2-flute carbide mill here, and I'm just going to come and skim the surface of this part to make certain that it's nice and flat to start this experiment. Now, some of you are going to want to know, what did I use as a coolant here? Well, it's not so much a coolant as it is a lubricant. And what I use for aluminum is a degreaser. We've spoken about this before, but in this case I just happen to have this all-purpose degreaser kicking around, so this is what I use. Now this isn't good to breathe, so you use it in small quantities, and it's not good for the mechanical part of your machine. This is going to kill your ways and your lubrication. So really, as you saw, I applied a very small amount just on the surface that I was cutting. Now let's take a closer look at that surface. So here's my surface. I can still make out my letter B and letter A, and I can see that I did 1, 2, and 3 passes. First and last pass in this direction, second pass in this direction. And I see I have something that looks like a checkered board finish. And that is a true indication that my cutter is really perpendicular to the surface of my part. Because regardless of the direction that I was cutting in, I'm getting a slight cut on my forward edge and a slight cut on my trailing edge. And that is, as I said, a real indication that my axis is truly perpendicular to this surface. So since that surface is flat, well, that's another variable that I can set aside that I don't have to worry about when I come to compare those holes that I want to drill. But it also raises an important point about these fixed round column machines, and that is that there's no pitch or yaw adjustment on these machines. And that means that head alignment is a problem. Now, if your head is slightly misaligned, and most of these machines are, well, you're going to have to live with it, or you can do what I did when I bought the machine, and that is loosen the 4 screws that hold the column to the base, and using shims and an incredible amount of patience, well, work your way to the point where the head is perfectly or as perpendicular as possible to the table. Now you can see an example of head alignment on a normal mill in this short video that I did on edge finding. So here's a link to that. And you can see that with the 4 bolts that hold the column to the base, well, you're really going to have to work at it to get there. But is it that important that the head be perfectly aligned or perpendicular to the table? If you're doing very, very accurate work, yes. But for most jobs, it's not that crucial. You know, if it's just very slightly out of kilter, especially if you use the method that I described earlier, that I said I would describe earlier, and that is the longest tool method. So let's head over to the whiteboard and explain the longest tool method. So here I have my part. This little purple line describes the part that I want to drill a hole into. And this dotted red line, the long one here, describes the spot on the part where I want to drill that hole. I have something that resembles a center drill for starting my hole, and a drill itself. This obviously much longer than the center drill. And what we would normally do would be to start with the center drill. So we'd set ourselves up to be able to drill that hole. What I would then do is take the center drill out of the chuck, back the Z-axis off because I need more room, install my drill, and drill the hole. And that is really no problem as long as the axis of rotation of the tool is perfectly perpendicular to the surface of the part that we want to drill. But really, is this a perfect world? And is there such a thing as a perfectly perpendicular spindle? Well, the answer to those 2 questions is no. The problem with positioning in the height axis, the Z-axis, is really the point of intersection between the axis of rotation of the tool and the surface that we want to machine. And part of the problem is that there are two ways of moving the machine in what seems to be a z-axis. We have the head or the table that can be moved up and down, which is the z-axis proper. And then we have the axis of the quill that can be used, as we use when we drill, to come down or come up. And oftentimes we think that's the z-axis also, but in reality it's the quill axis. And they don't affect positioning the same way. To see the difference between the z-axis proper and the quill axis, well, we're going to exaggerate a little bit. And we're going to take this drill and we're going to clearly set it up so that we have our intersection point, but that it's clearly out of alignment, okay? So we have our drill, we have our intersection point. Now if I replace this long drill with a stubbier tool, in this case a center drill, and if I move my z-axis, well, I'll note that the point of this tool will not intersect the part at the same spot that this one did. It's actually going to intersect it quite a bit to one side. And that misalignment is caused by the fact that I didn't move the axis of the tool, the quill. I moved the z-axis of the machine. Now, if I come back to my original setup, I have my point of intersection and my head is still way off. But this time I'm setting up for the longest tool. So I install the longest tool with the quill completely retracted so that I have enough room to work. Then I'm going to drill or do whatever, but not necessarily in this order. I'm going to want to start with the center drill. But I've set up for the longest tool. I'm going to replace the longest tool with the shortest tool, but I am not going to move the z-axis. When you're working on the longest tool, you want to set up for the longest tool with the quill completely retracted so that you can use the quill to bring your tool back to the part. And if you use the quill to bring your shortest tool to the work surface, well, you're going to be working along the same axis of rotation and your intersection point is going to remain the same. Now, once I've center drilled, if I back the quill off and replace with the other and come back down with the quill, well, I'll be working at the same intersection point. So that greatly increases the accuracy when we're trying to position tools. Now remember, we're not talking about something that is this crooked. We're talking of a few thousandths out of alignment and a few 10,000ths out in positioning. But if you want to work accurately, remember, setting up for the longest tool and using the quill will give you a better hole position. So this explains why I've said so many times to my students that when drilling on a milling machine, we use in preference the quill to the z-axis feed. However, sometimes the quill just isn't strong enough and we need a little more force to get a larger diameter drill to penetrate a surface. And when that's the case, well, yeah, we can use the z-axis for drilling. But knowing what we've just seen, you're going to know that you have to be careful to ensure that your drill is really perpendicular to your part. You don't want it to jam into the part because it's a little crooked. So check your alignment before using the Z for deep hole drilling on large diameter drills or with large diameter drills. Now let's get back to our little experiment and use what we've just seen, the longest tool method, to produce those 4 holes in that aluminum block. So I have my tools here. I have a 1/4 inch reamer. I have my drill, which is a 15/64 drill, and I have my center drill. Now the sequence of operations is going to be center drill, drill and ream. But for my setup, since I'm using the longest tool technique, well, I'm going to start by installing my reamer, which is my longest tool in this sequence of operations. And for the sequence, well, I'm not going to be using an end mill, I'm going to be using my chuck. So I'm going to swap the end mill for the chuck. There, my longest tool is in. I'm going to position it over the work part, for now just anywhere over the work part. And I'm going to verify two things. I'm going to verify that if at this height I can get this tool out without changing my Z on the head, and I can. And the second thing that I'm going to verify is if my shortest tool can make it to the surface of the part. It does, so I have no problems here. I can do the three operations in sequence without changing the height of my Z axis. So let's get this center drill snug down and let's get it positioned. Now for this experiment, all that really matters is the distance between each pair of holes. So not for the holes, the A pair to the B pair, but really the two holes that form the A pair, I want a certain distance. Where they are on the block really isn't that important. But what is important is that I reduce to a maximum all the variables. I want to control what's going on because I want to try and maintain as high an accuracy as possible between the two holes. So all that to say that where I'm going to put my first hole really isn't important as long as I know which direction I was moving in when I positioned that first hole. And for that I'm going to be pulling the table towards me and pulling the table towards the right side for my first hole. So that's the direction that I'll be moving in for that first positioning. And from there everything else will go. So once I get there, I'm going to take my piece of chalk, mark that position on the intersection between the table and the saddle, and then I'm going to set both my hand wheels to 0, and that's going to be my reference 0 for the three other holes. Some of you may be wondering why I chose a 15/64 drill for reaming with a 1/4 inch 4-flute reamer. A number of flutes aren't important here, but the diameter is. And if we recall, I think we mentioned this earlier in another video, we want to drill a hole 5% smaller than the reamer that we're going to use. Now, the reamer we're using is 250, and 5% smaller, or if you prefer 250 minus brackets 250 times 0.05 close brackets equals will give us about 237 thousandths of an inch. So I checked my drills out and I found that the 15/64 was 234 thousandths, or if you prefer, a 3 thousandths smaller than 5% of the reamer required. And that's close enough. So that's why we're using 15/64. It's our 5% smaller rule. So what we're going to be doing here is we're going to center drill the first hole. We're already positioned and we're zeroed up for it. So I've snugged up all my axes. I haven't locked them, but they're snug. I don't want any movement while we're drilling. So I'm going to center drill the first hole. Then I'm going to move my table over by 1 1/4 of an inch. Because I'm lazy, I'm going to have to measure the spacing between the holes edge to edge. And it's a 1/4 inch hole. So if I move the center over 1 1/4, that'll leave a nice 1 inch gap between the two edges of those holes. So once I've moved a 1 1/4 in my x-axis, well, I'm going to center drill the second hole, which is the A pair of holes. Then I'm going to move my y-axis over. How much? I'm not sure. It's not really important. We're only going to be making one movement in y. So I'm going to move my y-axis over and I'm going to drill the first B hole. And then I'm going to come back to my original point in X, and I'm going to drill the second B hole. But the sequence of those B holes is different. The A holes, and sorry to use that way, the A holes are just center drilled here. We're going to go finish them on the drill press to try and prove a point. But the B holes are going to be center drilled, and reamed. So once I move over to center drill the first B hole, I'm going to drill it also without moving. And then I'm going to go to the first B hole, center drill, and drill it. But then I have to reduce my RPM for the reamer. I'm going to want about 1/4 of the RPM that I was using for drilling. Since I'm drilling here around 1,000 RPM, I'm going to be using somewhere around 250 RPM for my reaming. So I'm going to reduce the RPM, ream my second B hole, and then come back to the first hole that I center drilled and ream it. And that should be all the operations required on this machine.
So there's my first center hole, the first A hole. Now I set my 0 at that hole, and now I'm going to move 12.5 turns. 12.5 because each turn is equal to 100 thou. And as I said, I want to go 1 1/4 inches for my second hole. And there you go. And there, that's the second A hole complete. So I can now move over for my first B hole in my y-axis. Now how much? Really not very important. And I'm not coming back on this movement. This is my only Y movement. So I'm not even marking my axis or setting the dial to 0 here. And there's my third hole, center drilled, or if you prefer, my first B hole. In order here, I'm going to, and I have center drilled my first B hole. Now I'm going to pre-drill my B hole, my first B hole with the 15/64, but I'm not going to ream it because that entails an RPM change. Then I'm going to go and center drill and drill the second B hole, change my RPM, ream that second hole, and then return to the first B hole with the mounted reamer and ream it. And that means that I can perform all my operations with only 4 movements. 1, 2, and 3 X movements, and 1 only Y movement. And when I reduce movements between the holes, well, I increase the probability that I'm going to have an accurate dimension.
Now I want to come back to my first B hole, or the one that I haven't done yet, the only hole that's left. And for that I'm going to have to come back to my chalk line. But remember, I set my 0 here with the chalk line and the table coming this way. So I'm going to have to go past my chalk line and come back to it. So I'm going to go past my chalk line by about half a turn, and then come back to the first zero I meet, and that will be the zero on my x-axis.
So I'm coming back to my chalk line, and there, just about there. Now I want to go another half turn further. There, I'm past my chalk line, and now I come back to my original zero. So I'm at my original zero in X, and I can drill that center hole.
So now I want to change my RPM from around 1,000 to down to about 250 for this reaming operation. Very important. We don't want a reamer to chatter. And when we are going to cut it, we're going to use a very positive feed. There's 4 flutes on this reamer, so it's really going to have to motor. So let's change the RPM. So the B holes are center drilled, positioned, center drilled, drilled and reamed. They're complete and they should be accurately positioned because I was very careful with my spacing of those holes. Now I was also very careful with the spacing of the A holes, but they haven't been drilled and reamed. They're going to be finished over on the drill press, but I want to control the variables. So this is no time to take that part out of the vise. I use this drill press vise for a reason, because I'm going to get the drill press vise off of the mill without moving the part in it. And I'm going to take that whole assembly over to the drill press and maintain a high level of precision. There, we're at the drill press and we're ready to continue with the drilling and reaming of the A holes. And that's probably long enough for the video this week. So this little quickie that is going to be over an hour long is going to be separated into 2 parts. It's the first time that I have a little quickie that's so long that I feel the need to cut it up. And that really indicates that I didn't think the title of this series through very much. You know, when I thought about video answers to viewer questions, a little quickie sort of came to mind, but obviously some of the answers are everything but quick. So we'll be back next time to complete this experiment, to look at some ways of maintaining head alignment on the round column mill, and to develop a general approach to that and some problems that are raised by those machines, those round column mills. So until then, have fun, be safe, and happy machining.